13.4 Methods for solving trigonometric equations. Number 1, isolate the trigonometric function if possible. So I want to make a connection to the warm-up today. Do you see number 4? Look at example 1. It is the same thing except instead of an x, it's a sine x. So what I want you to see is that all the different types of equations we have solved before, we're going to have trig functions in those places. And 2, factor. We're going to see one like number 6 where you can actually factor it. Number 3, if it doesn't factor, quadratic formula. We're going to see how to do that. Number 4, the squaring property. If everything else fails, we will go to that. So let's look at example 1. It says solve 2 sine x minus radical 3 equals 0 in the interval from 0 to 2 pi. Couple things to notice. Notice there's no or equal to here, so that means 2 pi can't be included. The other thing is, when you're first doing this, since this is Algebra 2 and we're still getting used to radians, do it in degrees and then at the end pop it back into radians. But your final answer should be radians, but it's okay to work in degrees. So in example 1, we're going to follow the warm-up like we did. You're going to add radical 3, and then you're going to divide by 2. Then this connects us to chapter 13. So please make sure you're not doing the learn, dump, because we have to use what we learned in chapter 13. So on the front board, do you see I have both triangles and I have my circle? Go ahead and write both triangles on your paper, your 30-60 and your 45-45 right triangle, and then the basic unit circle.
It's so nice outside today. It's a good day for soccer.
So then, looking at your triangles, what would the reference angle theta prime be to produce sine of that angle is radical 3 over 2. That's 60 degrees. Okay, so now watch how we're going to do this, you guys. And we're going to spend 3 days on this topic. Today, I've got it broken down to the textbook. The next 2 days, you'll get different worksheets, and we're going to practice. So here's the connection. All students take calculus. I need the sine of some angle that's going to produce a positive radical 3 over 2. So that is first and second quadrant. Well, in the first quadrant, it is 60 degrees. In the second quadrant, it's 60 degrees away from the x-axis. So how many degrees is that? 120. All right, then the last thing you're going to do is we need our answer to be in radians. Well, Carmel, what is 60 degrees in radians?
Pi over 3.
Good, pi over 3. And then think about 120 as 2 sets. Yeah, do you see that? Do you guys see that now? So that's 2 pi over 3. That's my final answer. Now, I want you to write kind of to the left on your paper because in each of these we're going to do an extra example. I'm going to call this example 1A. And we're going to solve 2 cosine x plus 1 equals 0. Again, from 0 to 2 pi. And I want you guys to try this one on your own. See if you're getting it.
Is that 2 cosine x plus 1?
2 cosine x plus 1. So Henry, can you help me out here? If I have cosine x equals -1/2 and I look at my triangles, what is the reference angle?
60 degrees.
60 degrees. Now here's the problem. I want it to be -1/2. So, Andrew, what two quadrants is cosine negative in?
The first and fourth. I mean, second and third.
Yes, you just did the opposite, yeah. First and fourth is positive. It's the second and the third. So I'm looking for a reference angle of 60 degrees into the second quadrant. So McKenna, what would be the angle in the second quadrant? 120, and then what would it be in the third quadrant if you went 60 degrees in?
240.
Good job, 240. All right, then Elena, what would 120 and 240 be in radians?
2 pi over 3 and 4 pi over 3.
Good job. 2 pi over 3, 4 pi over 3. Okay. Any questions on example 1 or 1A? So this is that first strategy. Isolate the trigonometric function. Okay? Let's move on then to example 2, and you can see how this was that 6th warm-up. But I'm going to do it a little bit differently. I didn't factor it. I did this. I subtracted the 2 from both sides. I'm going to do it differently than what the student did. And then I divided by 9. And I got tangent squared x equals 1/9. And then you get plus or minus 1/3. Well, this is not in either of the triangles for tangent, and it's certainly not on the circle because those are 0, 1, or -1. So what happens if I'm trying to find the angle and it's not in one of those 3 places? What do? You use your calculator, exactly. So since we want our answers in radians, please check your mode. So let me, check your mode, check your mode, check your mode. So I'll pull up my calculator screen. I'm going to check my mode. I'm in radians. And so then I'm going to do inverse tan 1 divided by 3. And it is giving me a value of 0.322. So this is theta prime, is 0.322. Now we need to stop and think, and this is what I absolutely love about Algebra 2, is that we're now doing a lot more thinking, okay? We want to focus on the thinking. We're not memorizing procedures. So let's think about this. I know all students take calculus. To get tangent x equals a positive 1/3, that's in the first and the third quadrant. To get tangent x equals negative 1/3, it's the second and the fourth quadrant. All right, so here's where it's going to get a little bit tricky. I do want it to be in all 4 quadrants, but I'm trying to work in radians now. 0.322 is a radian measure. So I'm 0.322 away from the x-axis in the first quadrant. Okay, that's no problem. But when you're working in radians, that's pi over 2, pi, 3 pi over 2, and all the way back around, a full rotation is 2 pi. So when I'm trying to get this reference angle in the second quadrant, it's pi minus 0.322. Does that make sense? If I'm trying to get here, normally we did 180 minus 60 or 180 minus 30. Well now, if I'm working in radians, it's pi minus 0.322, which I'm getting 2.820. Now, I'm trying to work into the third quadrant. So, does anybody have a suggestion? How might we find it? Good job. Yeah, you guys got it. So you take pi plus 0.322, which is 3.464. All right, then let's see how you're doing here with this last one. If I want to rotate 0.322 away from a full rotation, how might we do that?
You take 360.
Okay, but instead of 360, it's 2 pi, right? Good job. Good thinking there. So it's 2 pi minus 0.322. and that's giving me 5.961. Alright, let's go back over this one more time because this is one of the most difficult types. And it sounds like you guys have it down. You get your squared term alone. The most common mistake is that we forget the plus or minus 1/3, so be careful with that one. Second, when it's not on the 30-60 or 45-45 right triangle or the circle, you go to your calculator. I get the reference angle, and then you really put this in radians. I mean, I guess you could do it in degrees if you'd like, but then that'd be a much more difficult conversion for your final answer. So let's try to work in the radians if we can. So notice you're 0.322 away from the x-axis in each of the quadrants. Yeah.
Are these always going to be in radians?
Yes.
Okay.
Yeah. And we are moving in that direction in pre-calc. It's about 95% radians. It's rare that we go in degrees. All right, let's do another one. It does not necessarily mean that you're getting decimals on your calculator, but one that we have a squared term. So go ahead and try this. While you do that, I'm going to multitask like I always do. And this handout I'm giving you is actually tomorrow's classwork. I'm almost going to reteach the lesson again tomorrow with a little bit more freedom. So just tuck it away. It's not homework. Just go ahead and put it away for tomorrow. This is just classwork. It'll just save me time tomorrow. Oh, one other item I'll multitask with. This is part of tonight's homework. It's 2 more rational graphs. Because tonight's homework won't take that long.
Have we done 3 of these?
Have we done what?
3 of these.
Yes.
Can I get the first one?
Sure. Are you missing that one?
Yes.
It's not like this line sheet, this sheet's
I almost have everything done. I'll be ready to take the quiz tomorrow, the one I missed.
All right, that would be terrific.
Yeah.
Okay, on 2A, the first thing I did is I added tangent squared x. And then you have to do the plus or minus the square root of 3. If you look at a 30-60 right triangle, it's there. What would be my reference angle? 60 degrees. So theta prime is 60. Are you guys understanding that the plus or minus puts me in all 4 quadrants?
Because you're gonna have 4 answers.
Yes, because you'll have 4 answers here. So this will be 60, 120, 240, 300, because I'm 60 degrees away. So that's pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay, questions on that? Alright, we're going to skip example 3 today. I will do that tomorrow, but because of time and to make sure I get through the main types of solving today, we'll come back to the application tomorrow. Alright, example 4 says solve on the interval from 0 to 2 pi, sine cubed x minus 4 sine x equals 0. Something I need to make sure I talk about with you, and I hope I didn't gloss over this previously. If you see sine squared x, that is the way that in mathematics we write sine x times sine x. The reason why we don't write it like this is because students, that actually means sine of x squared. The x is what's being squared. So we don't put it out there. It's much easier, and you just have to get used to it. I guess it's the new notation. So when I'm doing sine cubed x here in this example, that literally means sine x times sine x times sine x. Okay? So what I'm going to do here on this one is I'm going to factor out the GCF. So remember, one of the strategies is to factor. So I have a GCF, and this is the first time we've had a GCF that's a trig function. Then sine squared x minus 4 is sine x plus 2, sine x minus 2. And if you recall from the warm-up today, one of my factoring problems was a difference of two perfect squares. And then if I solve each one of these using the zero factor property, I have sine x equals 0, or sine x equals negative 2, or sine x equals positive 2. If I think about my circle, what angle measurement in radians would give me the sine of that angle equals 0? It's in two places. Okay, give it to me in radians.
Okay,
Pi over 2. No, not pi over 2. You're leading me down the bad path. No, it's not pi over 2. Because look, remember, it goes cosine, comma, sine. So up at 90, it's 1. Sine of 90 is 1. So isn't it 0 and pi? There we go. Okay. There, I was following you. Now, look here. It says it cannot be 2 pi. And I'm not trying to trick you, okay, but this is the way the textbook writes it. So if it had said or equal to 2 pi, we would actually include 2 pi. Because 0 and 2 pi are the same point, but one's a full rotation around. This is saying all the way almost around. Now with these two, clearly it's not on the triangle or in the circle, but before you would ever hit your calculator, what do you guys remember? This is in the previous section when we graphed sine and cosine. Well, think about the graph of the sine function. Do you remember it starts at 0 and it oscillates like this? But it goes in between 1 and negative 1. So how on earth could we get sine x equal to 2? So this one doesn't work and this one doesn't work. But it doesn't mean no solution, because I do have two solutions. So you've got to be careful with your range. Yeah, Carmel?
Never mind.
All right, let's do an extra one of these. What if I give you 2 cosine cubed x minus cosine x equals 0? Okay, I'm going to give you a head start on me.
We're going to need it.
What I want you to do is I want you to talk with a neighbor and see what you see. See what you see. having some good discussion right now. I will tell you there are 6 answers. There are 6 answers. Okay.
I got half of them.
Okay.
If mine are right.
Well, for cosine x equals 0, so Elena, did you have pi over 2?
Yes.
And 3 pi over 2. All right, so how many of you had the pi over 2, 3 pi over 2? All right,
I
good.
had the pi over 2.
Now, with 2 cosine squared x minus 1, because this is the first time we've seen something quite like this, what you're going to do is, I expected you to struggle, and that's okay. I'm going to add 1, and I'm going to divide by 2. So then I have to take the square root. If I take the square root of both sides, I know the square root of 1 is 1, but the square root of 2 is 2. Now, somebody in the other class period asked me, well, shouldn't we rationalize that? If that were going to be our answer, yes, we would rationalize it. But when I go look at my triangles, which of the 2 special right triangles would give me an angle for cosine that's 1 over radical 2? Nice work. So the reference angle is 45 degrees. This is going to be in all 4 quadrants, right? So now x, and I can do this because I've gotten really good with my unit circle. This is pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Instead, I think it would be really yucky to try this one in degrees and then convert them. So if we remember our circle, that the 45-degree reference angles are all odd pi over 4s. Okay? How'd we do on that one? At least you understand it now. It was rough. Okay. It was rough, but I think we can. All right, last one, and then we'll do an extra one with it. This says solve cosine squared x minus 5 cosine x plus 2 equals 0. Now notice, this one says from 0 to pi. That's the first time that's changed. If you would try to factor this, do you notice that it's not going to factor? To get a positive 2 to add up to a negative 5, your only options are 2 and 1, and the best we can get is a 3 out of that. So this does not factor. So I want to show you a technique. If it doesn't factor, we're going to go to quadratic formula, but our unknown is a trig function. So what we're going to do is we're going to use something called U substitution. Okay, we're going to use U substitution. I'm going to let U equal cosine x, and then I'm going to rewrite it. So it would be U squared minus 5U plus 2 equals 0. So this is our quadratic formula. But you guys, this is really, really important, and I don't want you to think that I'm nitpicking because that is so far from the truth. When we use quadratic formula and we used x equals negative b plus or minus square root b squared minus 4ac all over 2a, it was because it was x squared, ax squared plus bx plus c. Our unknown was an x. In this equation right here, the unknown is a u. So if you put an x, that tells me you're not conceptually understanding what's happening. That x is this x, which is an angle, and that's not, you can't use it that way. So we're going to let u equal, it would be negative 5 plus or minus the square root. Negative 5 squared minus 4 times 1 times 2 all over 2 times 1. Now, in this case, it's assumed you know how to use quadratic formula, so you may use the program, okay? So pull out your program, enter A is 1, B is negative 5, C is 2, and it's going to spit out for you 2 values. Did you guys get 4.56 or 0.44? Okay, now, we're not looking for u, we're looking for x. U was a placeholder for cosine x. So we're going to plug it back in. And again, remember what I talked about previously. Algebra 2 is about thinking, thinking logically, thinking critically. if I look at cosine x equals 4.56, I should not hop to my calculator. What should I be thinking about with cosine x equals 4.56? Why can't it be 4.56?
Because it's 0 well, like, it doesn't,
0 to pi, pi is only
Yeah.
3.14.
What do you mean 0 to pi?
What was that one thing? Because it couldn't be greater than like a 1. It had to
Yeah.
be.
Yeah, you guys are getting mixed up here with 3.14. That has nothing, 3.14 isn't the output. You're thinking inputs. I mean, it can go 0 to pi. That's what I'm putting in. You're mixing up domain with range. It's right here. You guys remember what I just told you about on the previous example? Sine and cosine. The outputs oscillate between -1 and +1. There is no way to get cosine of any angle between 0 and pi to spit out a 4.56. Do you guys understand? You were talking domain when in fact you needed range. So we're going to cross that one out. Now here, I'm going to use my calculator. And you're going to do second cosine 0.44. And that's going to give me 1.12. And that's first quadrant, and because cosine is positive in first and fourth, and I needed an answer between 0 and pi, I'm done. Okay? Alright, let's try another one, because it sounds like we really need to hit this again. So let's look at sine squared x minus 4 sine x plus 1 equals 0. This time, no, we'll still do 0 to pi. If you look at it, you should take a moment to try to see if it would factor. There's no way to get a 1 to add up to a 4. I mean, at best I can get 1 plus 1 is 2. So we're going to do u substitution. I'm going to let u equal sine x. So I have u squared minus 4u plus 1 equals 0. Again, it did not factor. So do quadratic formula on it. Whoops-a-daisy, that is not it. Hold on. Alright, so when I did that, I got 0.27 or 3.73. Now remember, u is a placeholder for sine x.
And 3.73.
Yeah, and so remember, sine x can only spit out numbers between -1 and 1. That's the range. So this one does not work. So then when I do this, I get inverse sine is 0.27. So let's connect this. All students take calculus. It's first and second quadrant, so you've got to be careful with the sine curve. So it's 0.27 away. So I actually have a second answer, which would be pi minus 0.27, which would be about 2.87. So in this one, there were two answers. Okay? Any questions?